Hello friends, welcome to my channel. Let's have a look at problem 733, flood fill. So this problem asks us to change the color of the image pixels according to the neighbor relationship. So the problem asks us to return the modified image after performing the flood fill. So the flood fill is the following. So we consider the starting pixel plus any pixels connected forward directionally to the starting pixel of the same color as the starting pixel, then plus any pixels connected forward directionally to those pixels also with the same color, and so on. So we replace the color of all of the aforementioned pixels with the color. So that's the problem. Let's look at the examples. So in example 1, so we found the neighbors or the connected component containing this start position with the same color as the start position. That is 1. So we change all that to be 2, right? So this pixels above the diagonals so are all changed to 2. So this one does not change, right? So because it's not connected with 1. So in example 2, so this is sort of a trivial example. So let's look at the constraints for this problem. So the number of rows and columns are bounded by 50, so which is not a very large number. And the source position, RC, are within the image bound. So that's an consistency assumption. So in this video, we're going to share a traversal solution. So here we're going to present both breadth first search and depth first search. So here I'm writing the solution in an iterative way. So here are some comments. So first, so for breadth first search and depth first search, the corresponding containers are the following. For breadth first search, we shall consider queue, and for depth first search, we shall consider stack. So this problem is essentially locating the connected component containing the coordinates SR and SC, in other words, the source position. So therefore, we could use either unified abstract data structure or traversal. So here we shall present breadth first search and depth first search. So please try writing a parallel solution with unified. So it's actually very straightforward and natural. So here is one remark before we write the code. So to make the logic clear, first I'll try to find the connected component, then we do the color change. So actually after that, we shall do it in one go by simple modifications. So with that said, let's do the job. So actually, I imported a deck to use it either as a queue or as a stack. So it's not necessary, but let's do it. So first, I'm going to track the meta information from the image. So in other words, I want to track the number of rows and number of columns. So that is length image and length image, so the first row. Next, what I'm going to do is to write a depth first or breadth first search hyperfunction. So for this, I'm going to write them in iterative fashion. So let me use traverse. So IG. So first, I would like to locate the current color at this position IG. So I will see check equals image IG. So this way we should check the neighbors and also check if they have the same neighbor as check here. So that's it. Now let's initialize a container. So here I'm using deck. So we initialize using the IG. So we're going to pass this function with SR and SC later. So this is a container. It depends on how we pop the elements. It behaves like a stack or like a queue, corresponding to depth first search or breadth first search. So now let's do this thing. So first, I'll need also to initialize a set. So this set will store the coordinates, which is going to be a representation of the corresponding connected component, or in unified language, the corresponding cluster. So now let's do the while loop, while container. Then I'm going to pop to get the current position we are looking at. So let's see, container pop left. So if we pop left, actually we are using it as a queue. So this corresponds to breadth first search. If we use pop, so this will corresponding to depth first search. So with this position, then we are going to add this position visited to the set, and then we're going to look at its four neighbors. So for x, y, in, so r minus 1, c, r plus 1, c, and r c minus 1, and r c plus 1. So these are the four neighbors. We shall check if the neighbor is in range and it's not visited and also have the same color as the check. So this is the routine. So 0 less or equal than x less than m, and 0 less or equal than y less than m. And so we want to make sure x not invisited, and we want to make sure the image xy equals the color at the position ig. So if all these conditions are satisfied, let me put a parenthesis here for clarity here, and we're going to add this xy to the container. So I'm going to use container append this xy. So that's it. Now we're going to return the set representation of the connected component containing ig position. So that's it. So with that said, we are ready to do the last step, that is do the color change. So in order to do the color change, so first we're going to do a traverse. So traverse. So start from the SR and SC. So this way we located all the pixel positions we need to change. Then it's a for loop for I in range m, for R C in S. So just the image RC equals the target color, that is color. Then we're going to return the image. So that's it. Let's do a quick check for a special case. Yeah, it passes the special case. Now let's do a generic case check. Yeah, it passes the generic case. So this is we are popping left. We are using breadth first search. Now let's use depth first search. So let's check directly. Yeah, it also passes the generic case. So by now we have a solution for the problem. So next we want to modify this program a little bit so that we do all these things in one go. So let's copy this stuff, and I'll call this v1. Now let's look at the second one. So when we write the function here, so we can actually do things like this. So before we add, or after we add to visit set, then we're going to change the color of RC to the target color. And then I want to write this function like this. That's the color, right? And then what we want to do is that actually we do not need to return anything. So, and finally what we want to do is that we just need to call this traverse function. So source row, source column, and the color we want to change. And what we want to return is the image status. So that's another format of solution. Let's do a special case check. Yeah, it passes one special case, and then we can check for the generic case, and it passes. So we can also check, this is the depth first search. Let's also check breadth first search. Same thing. So I guess that's about it for this problem. So actually we started a playlist for graph algorithms. So if you have time, so you are welcome to watch and follow up. Thank you so much.